So I'm going to show you the system next, and then we are going to do some demos. So let's see how that will work. So put that up. Let's log in. So this is it. So it's now black, but I have a lot of different kind of even a custom theme that you can play around, but I kind of like the black, so I will keep that as it is. But yeah, so you just saw the demo. So now you understand that once you logged in, you have the message Ari Lipponen has entered the building, and then you can see the lobby. It's now active, and then you can see the different rooms. I have access to all of the rooms, but if I was one of my boys, they only would have access to playroom, and it would show that in different colors that the rooms to which they are not able to access. So let me go into control room. It asks the PIN code every time you enter to the room. So this is now the room display. So you have a participants card up in the upper corner, and then you have the available humans or AI entities that you can call out to the room. Because this is now a control room, I have only allowed a mechanic instance to be available here. So I can press the button, this is a wake up button, and then the mechanic is waked up. And now it's alive. Couple of words on the telemetry. So there is everything that you can see, there is a purpose. Gonna zoom in. So for example, the brain here, this is a calculator whenever the LLM is actually processing something. Large language model, LLM. But whenever you use some agent and you send something to be processed, this will now react. So you actually then see that the LLM or the agent is actually thinking something. Then you have there is a heartbeat. So I have separated all the agents in different processes. So basically all the agents have their own Linux process ID. And all of these processes are configured so that they are sending a heartbeat signal every 9 seconds. So this is the glitch or the indicator that you can see on the heartbeat sensor. If there is something problems in the Linux side and the process starts to crash or something, then this will turn red, and you will not see the signal anymore. Then there is lungs, and the lungs are for if the system has given access rights to the AI instance. So for example, it has its own service keys and the account in the Google Cloud. So I didn't say that. Everything here has been built on Google Cloud. So if the service keys or the service account itself is disabled, the lungs will go disabled. And I can actually show you, I have an admin tool here. So if I take the mechanic and I remove the key, so this is an access key, you can see that the lungs go flat. So now if I would ask something for it, it couldn't react because it hasn't had any access rights. But let's create the key back. Then the icons here. I decided to use icons. I know it might not seem that professional, but text would have taken a lot of space. So all the agents, they need tools. If you want them to do something, you need to create tools for them. And each of the icon presents a single tool. We can click that one, so it will list all the tools that I have created for them. I have a quite strict privacy architecture design on this one, so all the tools that I'm able to give them are something that I need to do myself. So the idea is that I try to keep all the data in the system and not put that to third-party systems. And then you can also see a role. So this mechanic, the name is mechanic, but it also has a role name mechanic. And the role basically is here. It states that you are the builder and maintainer of the system. Your responsibility is producing code, deep architecture analysis, and fixing bugs, together with human sovereign ARI. So quite simple. And the idea for me is that I will not instruct or give, restrictive information to the agents. It will be like given like this in a role, and this role will give them purpose. It will give them responsibility, and because they have roles, I'm hoping that they will react what is on their responsibility, and the weight values, for example, when they store memories, it's reflecting on the roles. So they are basically building their own identity based on the roles, not because I have said that you should act in a certain way. That's the whole idea, at least. So let's ask, hello mechanic. So you can see that the mechanic is now thinking and we have a reply. And oh yeah, the big thing here is that the entities and the agents, they don't reply directly to the chat. There is a buffer. It's a location between the chat and the agent. So every time they create a response, it goes to the buffer and they raise their hands. So you can see that the mechanic has raised their hand. It's saying that, hey, I need to speak, I have something to say, and the priority of my saying is 5. That's a neutral because the priority can be 0 to 9. 0 priority is a special one. It is a silent thought. So basically, if the agent doesn't have anything to say, it just says that, yeah, that's a great idea, but it doesn't produce any value. It can use a priority 0 and then basically just offer an emoji like a thumbs up. But whenever that happens, there is nothing going to be on the chat. But this has, so if I press pulse now, the pulse now is basically you are in control. So basically you are an orchestrator for this. So you basically run the meeting. So you press pulse now and there you will get the message. Simple as that. Why do I have the buffer there? Well, it's not necessary if you are one-to-one. But once you introduce more AI entities, then it's needed. And let me show you that next. So let's go to the boardroom. All right, that was thank you mechanic. You can go back to standby. So this now lives here. I have emptied all the rooms and tables are empty because I emptied everything before this demo. But let's go to the boardroom. Once again, we need to sign in. So I'm here. No one is active here. If some other person, human, would have been here and he or she would have, call out the entities, then I would just, be there I would join into their meeting and I would see all the discussions that they have already done. But this was totally empty. All the entities are dormant or sleeping. So let's wake up a bunch of entities. So let's wake up the demo entities that I wanted to show you, all 4 of them. So you can see that the demo 20, it doesn't have any tools. I'm gonna click the role. These roles are a bit more specific because of this demo purposes. But this role is basically a secretary for the meeting. And the idea for this one is that when I introduce a task for the whole team, this CTD20, CTD stands for Crash Test Dummy. So these are Crash Test Dummy entities. So it means that this should look out if they basically drop out the work before it's completed. So I have a multi-part task for the team and they just end up not completing it. So it should be a role for the CTD20 to step in and to say that, okay, maybe you have missed this point and you should continue. This is an experiment level, so haven't really experimented, is it working or not. All of these are, I created these demo entities 2 days ago. The 22 here, this demo has we open the tools, it has more tools, but this is a data courier, and basically it means that this is the expert for data transfer. So I have tools for the agents to write and read information from Google Drive and also locally from the server. So in the demo, what I'm going to need them to do is to read specifications from the VM, so the virtual machine, which is in the Google Cloud, and then write the results back to Google Drive. So this CTD22 is now the one that should act when it knows that it's time to act. Then we have CTD22. Once again, it doesn't have anything else but store memory, so it can write its own memory. But it's an analytical text refiner. So basically, if I need product information for some commercial, this will be the one to create the text for that. And then we have 23, and this is for creating visuals. So basically it has a tool called Nano Banana, and it means that it will create the pictures. And in the test that I'm going to show you next is that we are going to introduce a product, a random product, and there are some specifications on that. And I'm going to give them only a single task. And there is a multiple steps, and then we are going to see how they are going to handle that. And I showed you the information on the agent itself, so just a couple of words on this one. So this system, we can swap the actual LLM, so we don't need to be doing or using Gemini. But I'm now specifically done this for Gemini, but it's there, so the architecture is supporting that we can call someone else or something else as well. So not bound to the Google's Gemini LLM on this one. So we can define the model, and then we can define in which region we are going to call it. Google has many regions, but in my architecture I will try to put everything or try to configure the whole architecture so that everything is located in Finland. And the Europe North one is in Hamina in Finland, if you don't know. So that is my plan. So all the data will be here locally in Finland. And then we have a lot of data related to the context usage, because I need to monitor how much they are going to use the context, and then there are a couple of bullets on actually evaluating how much this agent is costing for me. these are quite experimental so far, but they are still there. And there you can see the heartbeat, which is pulsing every 9 seconds. So this is a real heartbeat that is coming from the backend side, so it's not in the front end. And the lungs, as I said, they are checking that the service key is created and the service account is enabled. All right, so then we start the interesting part. So just for you to understand the Google Drive, I will open that here. So this is a Google Drive. You can see 11 people here, but it basically means me and then all the agents. They are allowed for this one shared drive. So we should see some information there. And then I will show you VS Code. Let's code everything away. So we are going to store the information here. So this is actually now in Google Cloud. Well, everything is in Google Cloud when you're using Google, but this is the VM connected directly to the VM server, which is also where the software is running. So I'm going to create some specification on a random product here, and then call out the task on the program. And let's see how they are going to handle that.